Welcome to Conditional Probability using two-way tables. So work on the do now and resume the video to check your answers. Now this question does say to create a hypothetical 1,000 two-way table. So we're going to make our total 1,000. From there it says factory A assembles 60% of the cars. So you're going to go to the total for factory A and you're going to figure out that 60% of 1,000 is 600. And I'm going to put a 600 there. The next piece of information tells you that 70% of the cars made by this company, both factories combined, were highly rated. So 70% of the 1,000 cars is 700. And we're going to put that in the highly rated total section. And then lastly, 10% of all cars made by the company were both made at factory B and not highly rated. So 10% of the 1,000 is going to give you 100, and that goes in the intersection of factory B and not highly rated. From there, you used all the information that they gave you, and now you can fill out the rest. So 600 plus 400 is 1,000. 700 plus 300 is 1,000. 200 plus 100 is 300. 400 plus 600, 400 plus 200 is 600, and 400 plus 300 is 700. Just double check both ways, going up and down and left to right, to make sure everything checks out before you're done. So now let's talk about conditional probability. The previous videos have been regular probability in the sense that your denominator is always the total amount because you're always looking at out of everyone. What conditional probability does is it focuses in on a certain subgroup of the total. So now your denominators aren't going to be the total, your denominator is going to be a total of a category instead. So the official definition is the frequency of some event A given the occurrence of some event B. Now there are several keywords for conditional probability to look for. One is given that, of, if. So if you see any of these words and among, you know that we're talking about, hey, there's a condition going on. Find the probability given the condition or of this certain group of this condition. Do you get what I'm saying? So these are all keywords that are saying, hey, your total is not the overall total anymore. So our new fractions aren't going to be the cell over the overall total. Our new fractions are the number in a given cell over the marginal total for the row or the column. Just the total of a certain category. Now this notation is super important. This line means given that, which is another keyword for conditional probability. So this is read as the probability of A given that event B has already occurred. So it's definitely not a fraction, but you could think of it as a fraction in the sense that what comes after the dashed line is going to go in the denominator. But again, it's just a vertical straight line means given that. You do have to remember the notation to be able to read it. And just remember whatever comes after the slash or the keyword goes in the denominator of the fraction. So now you have three different symbols to remember. You have the symbol of A and B for and probability. You have the probability of A union B. The first one was intersection for or probability. And now we have the probability of A given that B has already occurred. So this is A given B. Or on the flip side, if you have B given A, it's just that your conditions have reversed. Let's actually try a problem with it. So I'm going back to your do now, because this was the table that we created in the do now, and we're going to answer some probability questions about it. So what I like to do is I like to circle the keywords and then highlight what comes after it or underline, because that's what your condition is and that's what should be going in your denominator. So I see a keyword. Given that, I'm going to circle it. Lets me know it's conditional. A randomly selected car was assembled in factory B. Automatically, I know that's my denominator. What is the probability that the car is highly rated? So I'm going to go to my condition, which is given that the car was assembled in factory B. And I'm going to highlight a factory B. Now I'm going to proceed with the rest of the problem. And I'm only looking at that column. I'm not looking anywhere else. So in this particular column, there were 300 highly rated cars out of the 400 total. So the probability is 300 out of 400. Let's try another. Among, keyword for conditional probability, the cars that were highly rated. That's your denominator. And automatically goes straight to the cars that were highly rated. That's where we're working for this problem. What is the probability that it was made in factory A? So in this column that I'm looking at, there were 400 out of 700 total that were made in factory A of the ones that were rated highly. Of is another keyword. Of the cars from factory A. So I'm going to go back to factory A. This is where I'm looking. Of the cars that were in factory A, was the probability that the car was not highly rated. So in this highlighted column, not highly rated, there were 200 of 600 total. So probability really requires that you read carefully and pick up on these keywords. Why don't you try this example and then check back in with the video to make sure that you're doing it properly. So for part A, you have the keyword being given that the student chose freeze time. So automatically freeze time is your denominator. And we're going to the freeze time column. Now, of the ones that chose freeze time, we're talking about them being male. So there are 71 males out of the 131 that chose freeze time. Your next one is of the, what is the probability that of the females? That's my denominator. and we're talking about them choosing super strength. So I'm going to move this out of the way, and I'm going to go to looking at all of the females. And of all those females, the ones that chose super strength was just one out of the 228. If, being the key word, a student prefers invisibility. And be careful because these are all bolded for you. Usually they're not going to be in a bold, they're not going to be bolded for you on the regions. You have to pick up on these on your own. So going to people who preferred invisibility. Of the 75 people who preferred invisibility, 48 were female. And the last one that we have is, what is the probability that, of being the key word, the students who chose telepathy? We're talking about them being female. So going over telepathy, we have 70 were female out of the 118 total who chose that. Let's try some regions questions. So going about this regions question, we have a survey about television viewing preferences was given to randomly selected freshmen and seniors at Fairport High School. And the results are shown below. They want to know, a student response is selected at random from all the results. State the exact, let's just say that exact means do not round. Please leave it as a fraction. Please leave all probability as a fraction. It's just easier. Anyway, state the exact probability. The student response is a freshman, given that the student prefers to watch reality shows on television. So this is your conditional probability. That is the key term. And the number of students who prefer to watch reality shows on television should be your denominator. Now, when you go to do this problem, you should realize there's an issue. And the issue is that the totals are missing. So we need to go and put them back in. You actually don't have to do the totals for everything, which is pretty nice of them. You only have to find one total, really. And that total is going to be for your condition that you're looking at. So our condition is that the student prefers to watch reality shows on television. So I only have to find the total for the reality show. Now, if there's 110 seniors and 103 freshmen, that means the total is 213. Of those 213, only 103 of them are freshmen. Let's try another regions question. So just looking at this one, you should notice that the totals aren't there either. You can go put them all in to begin with, or you can figure them out later, whatever you want. So using the data, determine whether a student with two older siblings is more likely to jog if one sibling jogs or if both sibling jogs, and they want you to justify your answer. So when we're talking about which one is more likely, what they're talking about is we have two different probabilities going on, right? You have to find the probability of both of them and compare them to see which one has a greater chance of happening. So you also have to notice that these are your conditions. We have two of them going on because we have two keywords. So let's go with the blue first. We're talking about if one sibling jogs. So here you go. And in order to do that, you need to find the total first. So my total here, if I were to add it up going vertically, I would have 2,239. And we're talking about determine whether a student with two older siblings is more likely to jog. So we're looking at the jogging column. There are 416 students who jog out of the 2,239 who have one sibling jogging. Now on to the other one, when we're talking about both siblings jogging. So I'm going to highlight this. This is what I'm looking at. And you need to find your total for that one as well. Your total for both siblings jogging is 1,780. So of the 1,780, 400 of them jog. So now that you found both probabilities, you have to figure out which one's more likely to happen. This is the case where it's best to convert it to decimals, right? Because it's hard to compare fractions, easy to compare decimals. So if you put in your calculator, you get about 1.858. And if you put the other one in your calculator, you get about 0.2247. So this one is greater, which means the one that's more likely to happen is if both siblings jog. Okay, last Regents question that we have. If you read this problem, if a person from the survey selected at random was the probability that the person texts over 50 messages per month, given that the person is between the ages of 23 and 60. So knowing me, pretty much 100%, because I text all the time, but not more than my students. So going over this one, we have our denominator. We're talking about the person being between the ages of 23 and 60. You should know that we are missing our total, so you have to go and fill it in. And your total for that column is 229. Now, if you don't have highlighters, what I suggest you do is you go and box in either the column or row that you're looking at. That way you don't go anywhere else on your table. Anyway, of that 229, we're talking about the people who text over 50 messages per month. So you have 157 out of the 229 people. And that's your probability. So a few things to keep in mind with conditional probability. One is that the denominator is not your overall total. The next thing is your keywords are given, of, if, among. There might be other ones that are also keywords, so just keep that in mind that it's not just limited to these four. Also, keep in mind that given tends to be one that's very confusing for people because sometimes the problem says given, but it's not conditional probability. Like, given is also an English word, so make sure that they're talking about given in the sense of finding probability. They can just say, given there are 1,000 people at this school, some like chocolate ice cream, some like vanilla ice cream, find the probability that I don't know, find the probability of the people who like chocolate ice cream. What I'm saying is given is used as setting up situations in problems like that. So make sure they're actually talking about a condition when you see this word. Usually it's going to be used for probability if you see find the probability that and given is in the same sentence. If given is not in the same sentence as finding the probability, then it is just a plain old English word and it has nothing to do with the answer of the problem. And next is the notation. So remember that P of A slash B means the probability of A given B. For example, if you see this, this is the probability of red given that they are female. So let's say we're talking about favorite color. So the probability that red is the favorite color given they are female. So please keep these several things in mind when working about conditional probability. The next video is going to talk about the formula for conditional probability, not just being able to find it from a two-way table. And that's all for this video.